about factor quadratics. So I've already underlined my coefficient, my constants. This is called the AC method. You identify the A, the B, and the C. So A is 2, B is 7, and C is 3. So A times C is 2 times 3, which is 6, and then B is going to equal to 7. So what I'm trying to find are the two numbers that multiply together to give me 6, but the same two numbers will also add together to give me 7. So we're going to go ahead and set up our X, and I use this like as a way to organize my numbers. So again, it's two numbers that multiply to give me 6, and the same two numbers have to add together to give me 7. So in this case, it's 1 and 6. So now we're going to use these numbers right here to expand the 7. So I say 2t squared plus 1t plus 6t plus 3. And then I take my function and I split it into half. So now I need to find the GCF in the first group. So the GCF is what I'm looking for. And in this case, it's 2. So I divide 2. So 2t squared is going to give me 2t. And then 1t divided by t is going to give me 1. And then in the second half, I need to find another GCF. Excuse me. I don't know what just happened. I need to find another GCF. And in this case, it's going to be 3. So 6t divided by 3 is 2t. And 3 divided by 3 is a positive 1. So what I want is I want these two to match. And then I'm going to create a new group with my GCF. So these two become t plus 3. And then my matching group becomes my second set, which is going to be 2t plus 1. And this is my solution. I have A equals 3, B equals 6, and C equals negative 35. So A times C, is going to be 3 times negative 35. That's going to equal negative 105. So I'm looking for two numbers that multiply to give me negative 105, but they also add to give me B, which is going to be a positive 8. So let's go ahead and set up our graphic organizer. Okay, so the numbers that I'm looking for are going to multiply to give me 105, but they're also going to add to give me 8. You're gonna have to go through like the list of multiplication. So in this case, I already know that the number is going to be 7 and 15. So because this is a negative number, one of these has to be negative, and this is a positive 8. So that means that the greater number will have the sign of the middle number, and then the lesser number will have the sign of the negative. So now we're going to use these two numbers right here to expand the center term. So I have 3n squared minus 7n plus 15n minus 35. And I take this and I split it. So I look at the first half and I try to find a GCF out of this group. So my GCF here is going to be n. So I'm left with 3n squared divided by n is 3n. Negative 7n divided by n is negative 7. And then my GCF is at n. Then I'm looking for a GCF within the second half, right? So the GCF has to be in each group, in each term. In this case, it's going to be a 5. So it's plus 5. 15n divided by 5 is 3n. Negative 35 divided by 5 is negative 7. So we know that we're doing something correct because our linear factors are the same. So then I take my GCFs and I make one group. So that's going to be n plus 5. And then whatever's left over is going to be our yellow group, which is our linear pair, 3n minus 7. And this is our solution. Okay, so number 3, our coefficients are 9 and 6, and our constant, or negative 6, and our constant is 8. So I take a times c, and that's going to be 9 times 8. That's going to give me 72. So I need to multiply to find 72, and I need to add to find b, which is negative 6. Set up our organizer. So I'm looking at 72, which is positive, and negative 6. So the two numbers that multiply to give me 72 but add up to negative 6 are going to be 6 and 12. Now, because this is negative, the larger number will be negative, and this will be positive. So these numbers right here are going to be used to expand our center term. So I'm going to say 9z squared plus 6z minus 12z minus 8. Now the first half, I want to think about what it is that I'm going to be factoring out of the first half. So I'm looking again for my GCF. It's going to go right there. And right now I see that it's 3z. So again, I get 3z plus 2. The second half, I'm going to factor out for sure a negative. So my GCF is going to be a negative 4. Remember, it's the greatest common factor. So I'm left with 3z plus 2. So when you divide a negative 12z by negative 4, you get a positive. So a negative divided by negative is a positive. So then I know that I'm on a roll when I have matching linear terms. And then I can say my GCFs will create one group, 3z minus 4, and whatever's left over in that yellow group, our linear factor is the second group, 3x plus 2. And that's my solution. Or a, b, and c. So a and b are the coefficients, 6 and 7, and c is negative 22. So I have a times c, which is equal to 6 times negative 22. I get negative 142. So in this case, we want to try and match b. So negative 142, and when the two factors add together, they're going to give me a positive 7. Okay, so you want to think about all the factors of 142, right? Because we don't know. So I have negative 1 times positive 142. The reason why I know it's a positive 142 is because when I add, remember, it's the larger number that takes the sign of the 7 that we're trying to build, the b. So 1 plus 142 equals 141. And then the other factors of 142, there's not many factors. The last ones are going to be 2, negative 2, and 71. So when I say negative 2 plus 71, I get 69. Okay, so if you can't find any factors, so there are no factors, right? So this is all the factors. And none fit. Then we call this prime. So in this case, this whole equation is only divisible by 1 and itself. And that's our solution. We have this negative right here. So we need to factor out a negative before we start factoring what's inside the parentheses. So I divide a negative 1 from each term. And so that's going to change the sign of each term. So I have 4r squared minus 33rt plus 8t squared. And then we're now going to look at our A, or B, or C. So A equals 4, B equals negative 33, and C equals 8. Now, C is also a coefficient. So I have A times C, 4 times 8 equals 32. So I need to multiply to find 32, and I need to add to find negative 33. So as we set this up, I have 32 and negative 33. So I have to think about the factors that multiply together to give me 32. So in this case, it's 1 and 32, but when they add together will give me a negative 33. So in this case, because 32 is positive and 33 is negative, so the signs were, I want to explain this. The signs were negative, positive. That means that both of my terms are going to be negative when I'm expanding. I also want to keep in mind that this -1, it's kind of just going to hang out, and we are expanding what is inside the parentheses. So the -1 is just going to hang out outside. So when we expand the center term, we're looking at 4r squared minus 1r t minus 32 RT plus 8t squared. And I want to make sure everyone understands. So we're just going to keep this on the outside. So when you factor the first half, we're looking for the GCF. My GCF here is going to be R. So I'm left with 4r minus 1t. And then my second half, my GCF is going to be, my pencil's really weird. So my GCF, sorry about that, is going to be negative 8t. And that means that my linear factor is going to be RT minus 1t. And again, we want to make sure that these match, and they do. So then I make a group for my GCF, and I have R minus 8t, and then my yellow group is going to go right here. So I have 4t minus, 4r minus 1t. Again, we don't want to forget this -1. This -1 has been here the whole time. So then I need to include that in my answer. So this right here is your final solution. I have A equals 4, B equals negative 23, and C equals negative 35. So A times C is 4 times negative 35. So I'm going to get negative 140. And I have to think about the numbers that multiply to give me negative 140. And they add to give me negative 23. Okay, let's see what those are. I have multiplied to give me negative 140, add to give me negative 23. So the factors that I'm thinking of are going to be 5 and 28. If this number, so if this is negative and this is negative, then the larger number will also be negative. So that means a 5 will be positive. So we're going to expand the center term. So I'm going to say 4x squared plus 5x minus 28x minus 35. I take my first half and I say my GCF. You don't have to do this every time. I'm just doing this for the notes purpose. So my GCF here is going to be x. So I'm left with 4x plus 5. My GCF in the second group is going to be a negative 7. So I'm left with 4x plus 5. Okay, so these two match. I bring my GCF groups down together. So that's one group. And then whatever's in yellow is a second group. But remember, they have to match. And this is my solution for 7. And let's go to number 8. So 7 and 8, it's kind of the same concept. So for number 8, if you notice, every one of these numbers is a even number. So I'm going to have to take out a GCF. So before I can start factoring, I'm going to take out the greatest common factor. In this case, it's 2. So I'm going to be left with 5q squared plus 7q minus 6. And I'm going to factor what's here. So this is almost like when we took out that negative 1. So that means my A is going to be 5, my B is going to be 7, my C will equal negative 6, and then I have A times C, which is 5 times negative 6. I get negative 30. So I want to multiply to get negative 30, and I want to add to get 7. So when we set this up, I have to think of the two numbers. And in this case, it's going to be 3 and 10. This is positive. So if this is negative and this is positive, my signs are going to be different. So I have a negative 3 being added to 10. So remember, these are always going to have, the 7 and the 10 are always going to have the same sign. So I'm going to say, I'm going to expand the 7q. So we're just going to keep the 2 out on the side and we'll put it in the answer at the end. So I have 5q squared plus 7q minus 6. I'm expanding the 7, 5q squared minus 3q plus 10q minus 6. The first half is going to be q, which is 5q minus 3. That's my GCF. And then my second GCF is going to be 2. So I'm left with 5q again minus 3. We want to make sure that these match. So I get a GCF group from here. So that's going to be q plus 2. The second group is going to be 5q minus 3. And then don't forget to bring down that 2. So the 2 is being multiplied by each linear factor. And that's your solution. Number 6, we want to factor out the GCF before we can start. In this case, the greatest common factor is going to be a 2. So I'm left with 3x squared minus 13x minus 10. And this, again, is what we're going to factor. So A equals 3, B equals negative 13, C equals negative 10. That's a C. So then I'm going to leave my 2 out here. 3x squared minus 13x minus 10. So it's going to be A times C, 3 times negative 10 equals negative 30. So I have to multiply to get negative 30, and I have to add to get negative 13. It's pretty simple. So it's going to be 10 and 3. So negative 13. So it's going to be negative 3 plus negative 10. So 3x squared minus 3x minus 10x minus 10. For the first half, my GCF is going to be 3x. So I'm left with x minus 1. My second half, my GCF is going to be negative 10. So I'm left with x minus 1. So my linear pairs match. And I match my GCFs together. So 3x minus 10 times my linear pair minus 1. And then I bring this down. It's a 2. And that's my solution. it's supposed to be an arrow. So it's 2 times 3x minus 10 times x minus 1a. We don't have anything to factor out, so we're just gonna go with the regular AC method. So a equals 8, b equals 22, and c equals 5. So in this case, we're gonna say a times c is 8 times 5, which is 40. So I wanna multiply to get 40, and I wanna add to get 22. So we set this up. They're both positive. That makes it easier. So I have 2 and 20. So again, they're both positive. So I'm going to get 8x squared plus 2xy plus 20xy plus 5y squared. Because we expanded the 22, I look at the first half, and I'm factoring a GCF of 2x, 4x plus y. Remember, that's my GCF. And then my second half, I'm factoring out GCF of 5y, so I'm left with 4x plus y. So these two match. This becomes my GCF group, my first one, 2x plus 5y, or my first group. And then the yellow becomes my second linear factor, 4x plus 5 plus y. This right here is your solution. Number 11, and number 11 is a little bit different because we are going to be factoring what's called difference of squares. So so what I have is two perfect squares at each end, and then I factor them to make two different linear factors. And this is how you check. So what happens is that there is no middle term. So if I think about what makes t squared the perfect square, I get t times t. If I think about what makes 9 a perfect square, I get 3 times 3. So another thing I want to highlight is that we have this difference of sign. So this is going to be a positive and a negative. So when we're setting up our linear factors, it doesn't matter the order, positive and then negative. So I put a t here and a t here. I put a 3 here and a 3 here. So that's my solution. And then if we look at something like number 12, if I have 9x squared, when I think about the two numbers or the two factors that multiply to give me 9x squared as a perfect square, it's 3x times 3x. And then if I think about 16, that's going to be 4 times 4. So you want to make your linear pairs. One's a positive, one's a negative. I'm going to put a 3x as the first term, and then 4 as the second term. And this is my solution. This is also a difference of squares. So we're going to set up our linear equations. So I have to think about the square root, right? Or the numbers that are going to give me that perfect square. In this case, it's numbers and letters. So it's 5pq times 5pq, and then 16 is 4 times 4. So 5pq and then 4, and that's your solution. I also want to do, we're going to do the rest of these. So I have 49x squared, so that's 7x times 7x. And then I have 4y squared, 2y times 2y. I set up my linear factors. One's positive, one's negative, so they're opposite signs. 7x, 7x. And that's my answer. Now, in number 15 and 16, we're going to have to take out a GCF because when I review this problem, I don't see perfect squares in each term. So we have to take out our GCF first before we can do anything. So that's equal to 2 times b plus 100. And then if you notice here, this is a negative sign. So there's a color you can see. This is a negative, but this is a positive. So this is the most we can factor this one. Number 16, taking out the GCF because I don't see any perfect squares. So it's 5. And then remember, we keep that 5 there. We'll write it at the end. So I have n plus minus, and then 4 and 4. So I'm not showing the example, but I can. So n squared is equal times n, and 16 is going to be 4 times 4. So at the very end, the very last step is to put it all together. So it's 5 times n plus 4 times n minus 4. You do not need to put that multiplication sign there, but I do. Okay, so for number 17, our GCF is going to be 2. So 2 is 25k squared minus 144 m squared. I like to just keep it there. So set up our inequalities. It's 25k squared, so that's going to be 5k times 5k. And then we have 144 m squared. That's going to be 12m times 12m. Then we bring it all together, right, like we did down here, or the one previous. So 2 times 5k plus 12m, and then 5k minus 12m. We're still looking at figuring out how to like the square root. So the square root of 18 would be like 9 and 9. But here's what's unique about that fourth power is that that's actually, or x to the fourth, that would be x to the second times x to the second. So what I do is I can take the exponent of 4 and divide it by 2. And you can do this with even exponents. So that's how I'm getting these different exponents. So going back to 81x to the 4, so this is 9x to the second times 9x to the second. And then I bring down the 16x to the 4, and that's going to be equivalent to 4x squared times 4x squared. So let's go ahead and start this right here. So again, you want to have a plus and a minus. It doesn't matter the order. We're going to fill in the linear sentences. So right now I have 9x squared and then plus 4x squared. And then the second one is 4x squared. And we're running into a unique situation here because this second number sentence, this is also the difference of squares. So I'm going to factor this again. So we're going to factor again. and I set it up. So again, I'm going to bring this down. We're just moving this down, and I'm setting up our linear sentences again. So if I have 9x squared, that's 3x times 3x. And then if I have 4x squared, that's going to be 2x times 2x. So I'm going to fill in my factors. So 3x, and then, 2x, not a 4x. So then finally, when we get our answer together, we want to bring down this factor. So our solution is going to be 9x squared plus 4x squared times 3x plus 2x times 3x minus 2x. And this is your solution. Okay, we can also look at 19. So as I'm factoring this, x to the 4th is going to be x squared times x squared. And then 625 is the perfect square of 25 times 25. So let's set up our factors. Remember, one's a plus and one's a minus. X squared plus 25. And then is x squared minus 25 is what we're gonna factor again. Because again, this is a difference of squares. And then again, we're just factoring what's in purple again. So I'm going to bring this factor down at my answer. So we're expanding this. So x squared is equal to x times x. 25 is equal to 5 times 5. X, and then our 5s. So our final answer is x squared plus 25. X plus 5. X minus 5.